Hey guys, Miss Davis here. If you are watching this, it's Unit 3, Skill 2, Regression Analysis. So take a minute, pause to write the essential question. How do we use regression analysis to write equations and solve real-world problems? Okay, so after you've written that down, we're going to read through the first example. Example 1 says the concentration in milligrams per liter of a medication in a patient's blood as time passes is given by the data. So over time, as you take a drug or any sort of antibiotic or anything like that, the concentration of it eventually dissolves and goes out of your system. But there is also a peak time when it's the strongest. So our table that they give us here is the x variable is time, or the independent variable, and after time, the concentration, or the y variable, the dependent variable, is listed there in milligrams per liter. So we're going to figure out how to write an equation that best models this data, rounding all values to the nearest tenth. So I'm going to insert a video on how to do this using the graphing calculator, because that's how you're going to do all of these. But the calculator steps are listed over here if you need to reference them on your own. So number 1, add new document, listen spreadsheet, label and enter data into list A and B, and then so forth. So then add a page to get your data and statistics. Again, you're going to see all of this done on the video. Then you're going to change the variables on the x and y axes. And then step 5, you're going to analyze to get your equation. You're going to see if it's either quadratic or exponential. So those are the two that you're thinking about. A quadratic function is that parabolic shape. So it looks like that U shape, and an exponential is going to be like start slow and then it's going to increase rapidly. That shouldn't be like a U there. It should be like horizontal on the bottom and then shoot up off to infinity this way. Okay, so that's a little refresher from Algebra 1. So I'm going to insert a video now to show you how to do that with this data. All right, so for example 1, the first thing that you want to do is add a listen spreadsheet. You can do that one of two ways. Is you can do it down here at the bottom, or you can hit 1, new document, add listen spreadsheet. So either way, add a listen spreadsheet. And what we want to do first, we want to enter our data into these two columns. The first one in A, we want to go up and highlight A and hit enter. So you should be doing this with me to practice. Hit enter and then enter your x variable, which in your problem is time or hours. So I'm going to write time using the keyboard below and hit enter. You'll see why in a second, why we're going to want to do that. And then our second column is enter, highlight B and hit enter, and it's concentration. I'm not going to write the whole word, C-O-N-C-E-N maybe, for concentration. And then go ahead and enter. And then under column A, we want to enter our data. So 0, hours, 0.5, 1, 1.5, 2, 2.5. And then we want to go back up. And 0 matches up with 0 from our table, 78.1, 99.8, 84.4, 50.1, and 15.6. Enter. Okay, so from here what we want is we want to be able to see what this data looks like on a graph and to see if it's quadratic or exponential. So what you have to do next is you have to add a page. So you're going to hit Control Document. So Control Document. And it says add. What we want is not another listen spreadsheet, but to add data and statistics. So it's going to display our data as these random scatter plots. So these dots all over are each one of our pairs of data that we just entered into our calculator. But what we want to do next is we want to tell down here, so click the x-axis, and we want to tell it what variable it is. Well, in our table, time was the x variable, or the independent variable. So we click on time so that it goes along the x-axis. But as you can see, our dots do not make any sort of pattern yet, or in terms of quadratic or exponential. So we want to change our y variable. And our y variable is after time, the concentration changes, so concentration. So as you can see, our dots are going up and then back down, so it makes that quadratic, that parabolic shape. So this is definitely going to be a quadratic regression equation. Okay? So the next thing, once you decided that it's quadratic, you want to hit Menu. And we have to get the equation for this. So hit Menu, or that line of best fit, which is what you might have heard from Algebra 1. So we're going to Menu, and then we're going down to number 4, Analyze. And then we're going to number 6, Regression. Okay? And then since we've determined that it's quadratic, or that parabolic shape, we're going to hit number 4. Okay, and then as soon as you hit that, it draws in that line of best fit, or that curve of best fit, and then there's your equation that you need to write down. Okay, so you need to write down that equation. If you need to move it over, you just go ahead and to see the rest of it, and drag the hand over it, hold it down, and now you can move it over to see the whole thing. Okay, so we're going to write that down that equation, but we're going to round to the nearest tenth is what your notes say. So we're rounding to the nearest tenth, so this would be y equals negative 56.2 x squared plus 139.3 x plus 9.4. That rounds to 9.4. So go ahead and do that. So now the next part B says, according to your model, so there's our equation. We wrote it here, y equals negative 56.2 x squared plus 139.3 x plus 9.4. Okay, now the second part B says, according to your model, what is the highest concentration in the blood? So round to the nearest hundredth. If you look in the table up here, you can tell that the highest concentration from the table is right there, but we want to use this model. So your model is the line of best fit, or the curve of best fit, so it's going to be slightly different because it doesn't go directly through those points. Okay, so I listed the steps here, so take your equation, put it into a new graph, and then analyze to get your maximum. But I'm going to insert a video now so you can see how to do that. Now the next part of the example, part B, says what is the highest concentration or the highest Y value in the blood? We're not going to use the actual dots from here or our table. We're going to use the line or the curve of best fit. So now that we have the equation of that, we got to go to the actual graph feature. So add a new document. So control document and add a graph. Number 2. And we're going to type in our new equation that we just got from our line, negative 56.2 x squared plus 139.3x plus 9.4. Get our graph. And as you can see, we cannot see the very top of our parabola. So what it's doing, it's coming up and then going way up and then curving back down. So what we need to do is change our y value. So double click on the 6.67. And we know that according to our table, at least it goes up to 99.9, or 0.8. So I'm going to change this to 100 to see what it looks like. And there you go. So there's our parabola. We can even change our x-axis if we want this more like widened. So I'm going to change the 10 there and change it to maybe 5. And then I have to change this one over here to a 0 because we're not going to use any of these values to the left. So we could do that if you want to make it look a little bit more zoomed in. Okay, so now we want the highest concentration, so we want the maximum point up there. So we want to go ahead, and these are review steps from last skill. We're going to hit 1, then we're going to hit analyze graph, number 6, and then we're going to have to find the maximum, so number 3. Okay, so now remember, drag your dotted line to the left of the maximum point for your lower bound, drag it to the right, and hit enter again, and there's your point, 1.23, comma 95.3. Okay, so that's the point we're going to jot down and write down in our notes, but they only want the highest concentration point, so we're going to only take the Y value. So the highest concentration was at 95.3 milligrams after 1.23 hours. Okay. All right, so I jotted down the point of intersection, or sorry, the maximum point right here for part B. And I realized, guys, that when I typed it in, I typed in a negative 56.5. So it didn't change it that much, but I just wrote down the actual decimal values that you should have gotten if you used the right equation. So I apologize. But if they want the highest concentration, that you're just taking the Y value, and you want to the nearest hundredth, so it'll be 95 point, we're looking at the 1 there, so it'll be 7.2. Okay, so that is the concentration in milligrams per liter. All right, and then part C we can actually do according to the maximum point. So according to your model, how many hours after the medication was administered did the highest concentration occur? Round to the nearest hundredth. So as you can see, the max point was includes has the hours, the number of hours of when the concentration was the highest. So in this case, it is just that the hours that it took for it to reach that max point is 1.2. We want the nearest hundredth, so I'm rounding to either 3 or 4 there, and the 9 after rounds it to a 4. So 1.24 hours. Okay. So now for the last example here, or the last part, according to your model, after how many hours to the nearest hundredth will the medication be completely out of the patient's bloodstream? So that means when is the Y, or the concentration, equal to 0, or it's going to be where it hits the x-axis. So it's going to be one of the zeros. And I'm going to insert another video to show you how to do that. Now, part D says, according to your model, after how many hours to the nearest hundredth will the medication be completely out of the patient's system, which means when will the concentration be 0? So down here at the x-axis. So what we want to do is find the 0, that point right there. So we go back to menu, go down to analyze graph number 6, and this time we want to find the 0, or where it hits the x-axis. So we're going to go ahead and drag our line towards the 0, hit enter, or the center button, and then to the right, hit enter, and then there you can see it. 2.53 is the number on the x-axis. So that's our answer to part D. 2.53 hours, the medication will be completely out of the patient's body. So again, I wrote down the actual value. If I use the right equation, it should be after 2.5444 hours is what your calculator should say. And rounded to the nearest hundredth would be 2.54 hours. Okay? All right, let's go ahead and flip on to the next page. And let's just take a moment to read example 2. So using a microscope, a researcher observed and recorded the number of bacteria spores on a large sample of uniformly sized pieces of meat kept at room temperature. A summary of the data is below. So after hours, the number of bacteria spores obviously increases. So using the data, write an exponential regression equation. So we know that if it's exponential, it's going to look like something like that. Okay, so exponential is going to look like that. Rounding all values to the nearest thousandth. So that's going to be decimal 1, 2, 3. So tenths, hundredths, thousandths. So we want 3 place values after the decimal. The researcher knows that people are likely to suffer from foodborne illness, if the number of spores exceeds 100, so is more than 100. Using the exponential regression equation, so step 1, we have to find the equation. So find the equation is the first part. So then after that, we will do find when it exceeds 100. But first, you're going to find the equation, and I'm going to show you how with another video. So for example 2, I already entered in the data into a new listen spreadsheet. So I entered our hours as our independent variable and the number of spores, bacteria spores, after a certain amount of time. So make sure that your table reflects this. When you type this in, we should end with 7 numbers in there. So end at 7, and that should be our ending data. So from here, we need to see it graphically. So we're going to hit Control and Document. We'll add a new page, and then go down to number 5, Add Data and Statistics. So we hit 6 again, and our data is randomly dispersed. So we want to add the variable so that it can categorize it and make it look like a pattern. So we've got hours is our independent variable on the x-axis, and now we need to organize them hours according to how many spores there are after that many hours. So choose your y variable as spores. So now as you can see, this is not quadratic, this is going to be exponential. So if you connect the dots, it'll make that sharply increasing curve that's going to shoot up to infinity there. Okay, so we know that it is exponential. So what we need to do now is we need to find that line of best fit again. So we're going to hit Menu, number 4 for Analyze, number 6 for Regression, and then we're going to choose Exponential. So number 8 is Exponential, and there you go. So there's your line of best fit, and this one is actually nicely through all of those points. So we need to write down this equation, rounded to the nearest, nearest thousandth. So it would be y equals 4.168, and then cut off all those decimals, parentheses 3.90981, and then the exponent is up in the, the x is up in the exponent. So if I scoot it over, exponential equations should always have the x up in the exponent. Okay, so let's go ahead and take a minute, pause, and write that down in your notes. Okay, so there's the equation written down with all the decimals, and we want to round to the nearest thousandth, so there and there for both of them. So it'd be y equals 4.16, that rounds up to an 8, times parentheses 3.98. The 0 gets bumped up to a 1 to the exponent of x. Okay, so there's your equation. Now part 2, I have another video to show you how to find when it exceeds 100 spores, so go ahead and watch the video right now. Alright, so for the second part of the question, I know it's a big paragraph, but break it up into 2 parts. Now we need to know when the number of spores exceeds 100. So we have to go to the graph for this one. So go ahead and add a new graph and type in your equation rounded to the nearest thousandth and hit enter. And there's our exponential curve. Okay, so what we want to do is we want to now graph the line y equals 100 because we want to figure out when is this going to hit 100 on the y-axis, or sorry, in the y direction. So we can't see 100 because y represents the number of spores. So what we want to do is we want to go up to that 6.67 and change that so that we can see 100. So I'm just going to go up to 110 or 120. Could anything be great or anything greater than 100? Okay, so there we have our curve. Much higher we can see way farther up. So now let's hit tab and we're going to graph the equation y equals 100, just regular 100 with no variable, and hit enter. Okay, so now that intersection point right there is what we want to know because that will tell us exactly after how many hours our spores will hit 100 and will then exceed 100. So go ahead and hit menu. We're going to analyze graph, so number 6. And then we want to find number 4, the intersection point. So remember we did this in the previous video where we want to hover the dotted line, hit enter to the left of the intersection point, and then drag it to the right of the intersection point and hit enter. And then you can see that it says 2.3 comma 100. So that's the number that we're going to write down in our notes, and then we'll interpret it from there. Okay, so I have listed here for number 2, here's our point of intersection where they met. And so it says specifically, using the exponential, determine the maximum amount of time to the nearest quarter hour. So quarter hour, so our x variables are hours. So we got to think about, is it closest to which quarter hour? It's either going to be 2.0, 2.25 is a quarter hour, and then going up to the next quarter hour is 2.50. So think about counting up by actual quarters, 2.75 and so forth. So which one is it closest to? 2.30 or 2.3 is definitely closest to 2.25. So our final answer here is going to be 2.25 hours is when it's going to exceed 100, or it might be written as 2 1/4. Okay, so that's your answer. I've also have it listed over here to the right, the steps on how to actually do this in case you want to look back in your notes. So type your equation into the graph, first step, and then adjust your window is very important so you can see all the way up. Type in your y equals 100, and then find the intersection point and write it down. Okay? All right, go ahead and take a moment to reflect and write your summary, please. And then practice.